Okay, so this lesson is 3-7, and lesson 3-7 is broken up into two parts. It's all about transformations of linear functions. So taking a line on a graph and moving it, whether you're shifting it up, down, left, right, reflecting it, or compressing and stretching it. So our vocabulary for this part is right here. So we have translation, which shifts the line of a graph vertically or horizontally. For our class, we're only focusing on vertical transformation or translations. Okay. And all of these are called transformations. And as you can see, we have 4 transformations that we are going to be talking about. This first page discusses translations, which we did yesterday, but I'm going to do again today. Reflections can either reflect across the X or the Y axis, and the rules for those are very specific. If you reflect it across the X axis, you're multiplying your slope and your Y-intercept by -1. If you reflect it across the Y-axis, you only reflect the slope by -1. I mean, you only multiply the slope by -1. And then we have a stretch and a compression, and I will discuss those in more detail when we get there. The last word is a parent function. This is the function that goes through the origin and has a slope of 1. Sometimes I refer to the parent function as the first function that you graph. And then the next functions you graph are the transformations. Okay, so let's go ahead and look at vertical translations. When we're talking about a vertical translation, we're talking about shifting it up or down, okay? And when we shift it up or down, all we're doing is we're changing the Y-intercept. We are not changing the slope at all. So the first thing that I want you to do on both of these examples is to graph this equation, and I want you to graph this equation. And then we're going to go through what to do with both of those equations. So this one is the same as y equals 1x. And this one is the same as y equals x plus 5. So if you can graph both of those, and then we'll come back and do the translation. So I'm going to pause the video. Okay, so now that we have our line graphed, we have the function f of x equals x. So this is what I graphed, and I labeled it f of x. And it wants us to now take this function and shift it 3 units up and label it g of x. So that's what we're going to do right now. When you shift it up, you just take every point that you graphed and you shift it up 3 units. So I'm going to take this point and shift it up 3. This one's 3, this one's 3, and you'll see a pattern here that the slope remains the same. It's 1. And the only thing that you did was change the Y-intercept. Okay. And then we can draw that line and label this g of x. Once you do that, we need to describe what is happening. So our new equation is no longer x, but it is g of x equals x plus 3. And so you're going to notice that we only changed the Y-intercept from 0 to 3, but we left everything else the same. Our slope did not change. It stayed the same. The x-intercept changed, and the Y-intercept changed. Okay. All right, let's go to the next example here. You should have a graphed line, x plus 5, and now they want us to take and shift the line 3 units down and label it g of x. So I'm going to shift this one 3 units down, and of course my slope is going to stay the same. And g of x, and this one. And then we're going to write our new equation. So it's still going to be g of x equals x, but instead of plus 5, since we shifted it down 3, we subtract 3 from the y-intercept and we get plus 2. Our slope stayed the same, but our x and y-intercept both changed. All right, any questions on that? Okay, on example 1, I want you to graph both your f of x and your g of x. Okay, and then I want you to describe what is happening down here, and I want you to do that one on your own. Okay. So I'm going to pause the video while you do that. Okay, so on example 1 right here, I have my 2 graph lines. My slope stayed the same, my x and y intercept changed, and now it wants to describe the translation or the transformation. So when you guys are describing the transformation on your homework, I want you to not only name the transformation, but explain what happened. So for example, this is a translation. And you would describe it as 4 units up. So make sure you're doing that on your homework, okay? All right, any questions about this? Oh, one thing we did highlight yesterday on the notes is, get my highlighter, is the rule for a vertical translation. And this is what you need to, I'm gonna use a different one. This is what you need to keep in mind, is that you are adding or subtracting from the y-intercept only. You leave the slope alone, okay? All right, let's go to page 2. Now this is where we're picking up from Monday, so everybody should now be on your notes on page 2. So we're moving from translations, which is very simple, to reflections. And the one thing you need to note the difference of is the difference between what you're doing to an equation when you reflect it on the x over the x-axis versus over the y. So your reflection across the x-axis, it flips the parent function across the x-axis, and here is your rule. You're multiplying the entire function by -1. That is what you're doing. So what does that mean? Okay, look down here at this equation. We have our first equation, f of x equals x. And we have our second equation, g of x equals -x. Notice that we multiply the slope by a -1. And since we don't have a y-intercept on this, or we do, it's 0, our y-intercept still stays 0 because -1 times 0 is still 0, okay? So what I want you to do is I want you to graph f of x equals x and label it f of x, and then I want you to graph g of x equals -x and label it g of x. And I'm going to pause the video while we do this. Okay, so here is a reflection across the x-axis, but you'll notice that this is also a reflection across the y-axis. It's across the x and the y. So anytime you have a slope of 1 with a y-intercept of 0, when you reflect that, it will be both a reflection across the x to y. Okay, that's the only time that that will happen. Okay, so now let's go over to this next example, and we're going to graph 2x plus 4. And we're going to graph it across the x-axis, and I'm going to show you how to do that. So I call it manually, okay, by hand versus by equation. All right, so let's go ahead and graph this equation first. And label it f of x. Now, when I graph this by hand without looking at my equation, all I do is I take a look at the x-axis, and I know that this line has to flip over this. It has to mirror my x-axis, okay? So I take each point and I count how many units it is away from the x-axis, and then I go in that opposite direction, or in that same direction, actually. And I go that many units on the opposite side of the x-axis. So for example, if I look at -1, 2, it's 2 units from the x-axis. So I will go 2 units from the x-axis on the other side, 1, 2, and plot a point. Okay. And I will do that with every point. So look at the y-intercept, it's 4. It's 4 units from the x-axis, so I go 4 units down on the other side of that axis, down. Then I do that with the other one, 6, and I go down 6. And then 8. And you can kind of see the pattern here. What do you think is going to happen with the x-intercept, where it crosses the x-axis? Luke? Yeah, it's going to stay the same. This doesn't move. It's already on the mirror, right? It's on that axis. So then I do the same thing to the opposite side and go up. And draw my line. So are there any questions on how I did that? And we will label this one g of x. So what I want you to do is I want you to look at the line, and I want you to figure out the equation of that line. And you're going to start with g of x. Someone want to tell me what that equation is? Abby? -2x minus 4. Good. So what do you notice about the slope? What happened with our slope? Yeah. It changed and it became the negative of it. So we call that the opposite. Okay. What about our x-intercept? Stayed the same. And our y-intercept? Yep. And it is also the opposite. Meaning that all we did was we took the same equation we started with and we made our slope and the y-intercept its opposite, or multiplied it by a -1. So that's what you're doing with the equation. So now what I want you to do is I want you to do example 2 on your own. You're going to graph f of x equals x plus 1, and then you're going to reflect it across the x-axis and fill out the descriptions. All right, and I'm going to have you do that on your own, and I'm going to pause the video. Okay, so when you're finished, it should look like this. And I want you to notice the description. Not only did I say that it was a reflection, but I specified that it is being reflected over the x-axis, even though that's what it already told us to do. Okay. Any questions on this one? All right, let's go to a reflection across the y-axis, which is page 3. This flips the parent function across the y-axis, and you only multiply the slope by -1. Why? Because it has a y-intercept, and the y-intercept will stay the same because it's reflecting it across that y. So what I want you to do on all 3 of these graphs on this page, I want you to reflect the original, I want you to graph the original function, okay? And then we're going to go through reflecting all 3 of those original functions. Okay, so graph all 3 of those, and I'm going to pause the video while we do that. Okay, so this is the original function, and it's telling us to reflect across the y-axis. So when we reflect across the y, we have to remember that we're reflecting across this right here. So it's the opposite of what we did. So now every point is the same distance away from the y-axis on either side. So This point at 3, 1 is 3 units from 1 on the y-axis. So I have to go 3 units from 1 on the opposite side of the y-axis. Okay. And then we have 4, 2. So it's 4 units away from 2. So I go 4 units in the opposite direction. And that's how you do it by hand. To me, I don't like doing it that way. I like following the multiplication rule of just multiplying your slope by a negative. So if I were to do that, my slope is 1, positive 1. So when I multiply my slope by a negative 1, I get negative 1. And I leave my y-intercept the same. So negative 1x minus 2. And to me, it's easier to graph that than to count the points and all that. So ultimately, I would just plot this right here and have a slope of 1. Any questions on that? Okay, so let's do this next one. If I wanted to just change the equation first and then graph it, somebody tell me what we're going to do with this equation to just change it and then graph the equation. Claire? And what happens to the y-intercept?
The y-intercept stays the same.
Yep. So 2 times negative 1 is negative 2. And our y-intercept stays the same. And so that's the equation I would graph. I want you to go ahead and do example. Oh, wait, we didn't fill this out. So our slope is the opposite. Our x-intercept change, it is the opposite. Oh, I'm running out of ink. And our y-intercept stay the same. Okay. All right, you go ahead and do example 3 on your own. Okay, go ahead and check your answer. Jason. Okay, are there any questions on the reflection?
Well, can you wait a second?
Oh, yes, I can wait a second. Okay, let's go ahead and move on to page 4. We're now going to go into compressions and stretches. Our book calls it slope changes because we are changing the slope. When you stretch, is that what I put on both of them? Right. Okay. Hey, chill out over there. All right. So when you do a slope change, it changes the steepness of the slope. Slope changes, y-intercept does not. All right. So multiplying the function by a number greater than 1 causes the graph to become steeper. But when you multiply a function by a number between 0 and 1, it causes the graph to become less steep or flatter. And I want you to label this. Okay. This one is a stretch. And this one is a compression. And I want you to use stretch and compression in your vocabulary rather than steeper or less steep. Okay. So use stretch and compression. All right. Steeper is stretch, yes. All right, so let's look at our first one. What I'm going to have you do is I want you to graph all of the original equations on all three of your graphs, 2x plus 5, 2x plus 5, and then down here it's 3x plus 2. And then we're going to come back and see what a stretch and a compression look like. So everybody needs to graph those three equations first. Okay, so for this first one, what it's telling us is that we need to take m, what is m? Slope, and we need to multiply it by 2 and rewrite our equation. So let's go ahead and do that with this one. F of x equals 2x plus 5 becomes g of x equals 4x plus 5. Okay, and then we're going to graph that. So go ahead and graph that equation. Okay. What happened to our slope? Yeah, so increase, or yeah, you can put steeper. I messed up. All right, what happened to your x-intercept? It changed. The y-intercept stayed the same. And the transformation, was it a compression or a stretch? Yes, stretch by a factor of 2. So stretch by a factor of 2. That's how you will describe your stretches. A factor of 2 meaning factor is multiplying two numbers together, right? So we have a factor that we multiply our slope by. Okay. Which axis did it come closer to? Did it get closer to the x or the y? The y-axis. So up here where you put stretch, I want you to put an arrow and put closer to y-axis. Okay. So compression is going to get closer to the x. Yeah, so you can put an arrow here, closer to x-axis. Now, when we look at this second one, notice that it is a fraction. This is less than 1, but greater than 0. So anytime that you multiply it by a number between 0 and 1, then you're going to end up with a compression. It's going to get closer to the x-axis. So if we multiply our slope of 2 by 1/2, what happens to our slope? What was that? You get 1. So now our new equation is x plus 5. So I want you to go ahead and graph this equation. And then I want you to notice what happens to each part of this line. So what happened to our slope? It got flatter or flattened. Our x-intercept changed. Our y-intercepts stay the same. And the transformation, if I can talk, the transformation is a compression by a factor of 1/2. Okay. All right, now I want you to do the example at the bottom on your own, and then we'll come back and check it. Okay, so this is what you should have gotten. All right, any questions? Okay, I'll leave it here. Okay, let's go to the last page. We are going to be applying multiple transformations. So you're going to graph and label the starting function. You're going to transform the starting function according to the directions and label this second function. So whatever it tells you, g of x. Transform the second function according to the directions and label this the third function, which is going to be h of x. And then continue until all transformations have been made. Okay. So we're going to start with A. A tells us to graph f of x equals 3x minus 2. So I want everybody to start with that equation. Okay. And then make sure you label that f of x. That tells me which line is graphed where. Okay. Letter B tells us to translate this line 2 units up and name it g of x. There's two ways you can do this. You could actually move each point up 2 units, or if you know the rule, you could just change the equation and graph that. I know that the rule, when you shift a line up, you're going to add to the y-intercept. If you shift it down, you subtract from the y-intercept. So since I'm shifting this 2 units up, I'm going to add to the y-intercept. And what does my y-intercept become? 0. So my new equation is g of x equals 3x, because negative 2 plus 2 is 0. Now, if I didn't know the rule and I just wanted to maneuver my line first, then I'm going to take every single point and shift it 2 units up. Okay, and then you could draw your line and label it g of x. Okay. Line C, or letter C, says to reflect this new line over the x-axis and name it h of x. Every time you go from step to step, you start with the latest line that you created, not your original. So now I'm going to take g of x and I'm going to reflect it over the x-axis. Does anyone remember the rules to the equation? Luke? Multiply it by -1. Multiply the whole thing. The whole thing. So I'm going to take g of x equals 3x and multiply my slope and my y-intercept by -1. So that means that my new equation becomes h of x. Oh, really? H of x equals -3x. Okay. And I'm going to graph this. So 0, and then I am going to go. Now, if I didn't know the rule, I could just reflect each point over that axis, which is actually the x. And D says to stretch this new line by a factor of 2 and name it K of X. When we stretch by a factor of 2, what do we do with our equation? Multiply the slope by 2. Yeah, because it's asking us to stretch it by a factor of 2. So when we multiply h of x, the slope of h of x by 2, we get k of x equals negative 6x. Okay, and so now I'll graph that. Which now only do 2 points on this one. And you're going to see a messy graph, but try to make it, use a ruler for this assignment and try to make it as clean as possible. Okay, what I would like for you to do now is I want you to do example 6 on your own. This is the last one, and then we will move on to part 2, possibly. Okay. Okay, here is the answer to 6. Check your equations and your lines. And this concludes lesson 3-7, part 1.
Oh, yes. Oh, yeah. One more. Oh, yeah.